Hey logical people, GKV here, and here's the promise. By the end of this tutorial, we will have a fully functional Twitter-like application where anyone can use their wallet to connect and start publishing tweets. You will be able to view all the tweets sent to the blockchain. You will be able to filter tweets based on the author. Example, Elon Musk, if you may. You could also go to my tweets page to see all the tweets that you have tweeted. You will be able to post a new tweet on Solana Devnet, of course. You have to sign and pay the rent using Phantom Wallet. Approve the transaction and then it directly goes to the Solana blockchain. And you can find all your tweets under my tweets section. And there it is. Last but not least, you can click on this link and you can view your tweet on the Solana Explorer. So without further ado, let's get started. Alright, so before we dive into the details of the tutorial, let's start by having a quick overview of what we are trying to achieve. I will also list few prerequisites that should help following the video, of course, but there's nothing to worry, there's nothing too drastic or dramatic. Then that is because we are building everything from scratch after all, but it is recommended that you go through all the prerequisites that I'm going to mention in a moment, so that following this video and mastering Solana is rather easy for you. Okay. The first feature that we want to talk about is that user will be able to integrate their wallet, in our case Phantom. Users will be able to log into the application using their wallet, of course, and logged in user will be able to send tweets up to 280 characters, right? Of course, user will be able to read and write tweets, but they can also use our app as a read-only mode without needing to be logged in, right? User will be able to filter out tweets for different authors, for example, Elon Musk, for you, for me, by using their public keys, right? Last but not least, everything will be public, so you can actually go back to Solana Explorer and you can check out when and which tweet was published, who published it, and things like that. And everything will be working on the Solana blockchain, so that will be our central theme to learn in this tutorial. I hope you're extremely excited, because I am, and I think you should be able to tell it. Nonetheless, before we dive into the Solana world and the blockchain world, there are a few prerequisites that I think are worth mentioning. And there aren't many prerequisites for this video because we're going to build everything from scratch. However, acquiring some knowledge might make your journey smoother, and therefore I think they are worth mentioning. The first thing I would say is you should have some programming background. It might go without saying that we're going to create an application from scratch, and if you got no or very little programming experience, then you might want to start with simpler tutorials before embarking on this journey. I'm not being harsh on you, but this is the reality, or let's say blockchain technology in general is rather difficult. So it's always advisable that you have some programming background. Second prerequisite is having a high-level blockchain knowledge. While I'm going to try my best to explain all the Solana concepts that you come across, however, having some high-level knowledge on how blockchain works will greatly help. Here's a video that I created, and I highly recommend that you go and watch this. I'm going to put the link of all the videos and prerequisites in the description box, so I highly recommend that you go and check on that. Okay. The third prerequisite that I think is important is Rust. Although Rust experience is not required, Rust has some pretty unique features. If you have got some programming experience, you should be able to understand what Rust code does without doing much. However, in general, we're going to use Anchor framework, which is built on top of Rust. So it is recommended to understand how Rust works. Last but not least, I think you should have some understanding of how JavaScript works. Since we're going to use Next.js as a front end where user can, click on a button and, fetch some tweets or create new tweets, I recommend that you go and, at least watch this video where we talk about how Next framework works. Okay. It's going to be a real asset for you if you understand or have all these prerequisites under your belt, not just for this project, but any project that you want to work on in future. Okay. Beautiful. The last prerequisite that I've kept as a separate is actually installing Solana on an Ubuntu laptop or on a Linux on a Mac. I have tried and I've really tried it hard to install Solana on Windows, but as of now, recording this video, Solana is not very compatible on Windows. Therefore, I would recommend that you either install Ubuntu. So I'm going to work on Ubuntu in this video. But you either install Ubuntu on your machine by using a partitioning, or you can install Ubuntu in a virtual environment, whichever makes you happy and whichever is easier for you. And I'm pretty sure there are plenty of videos on internet how to install Ubuntu along with Windows or into the Windows. So once you have that operating system with you, I recommend you go and watch this video where I explain everything from scratch, how you install Solana, Rust and Anchor so that you're up and running for this project. Okay, beautiful. All right, so the first thing that we want to do is we want to select a folder where we want to initialize our project. So once you have decided which folder you want to use, right click, open in terminal, and here you need to type Anchor in it and the name of the project like this. Okay, and this will basically create and assemble everything that we need to get started. So once you have your project ready, I'm going to open this in my Visual Studio Code. Click on File, click on Open Folder, then select the folder. You don't need to go inside the folder, just select the folder and click OK. Now this will give you a couple of files and folders. You should have watched the video that was recommended to understand files and folders. Nevertheless, it gives us two important folders. One is program, which gives us a source, and lib.rs, and that gives us a very basic project. And we also have our test folder where we have our test already written for us. Okay, we're going to start with lib.rs, and here we need to design our tweet struct. Okay, so let's start doing that. All right, now is the time to understand some basics of Solana blockchain, how it is designed and how it works. So everything is an account. In Solana, literally everything is an account. And this is a fundamental concept that differs from most other blockchains. For example, if you have ever created a smart contract in Ethereum using Solidity, then you ended up with a bunch of code that can store a bunch of data, and then you interact with it, right? So you have an Ethereum world. Within that, you create a smart contract, and that contract will contain the code and data as well. However, that is not the case in Solana. In Solana, if you want to store data somewhere, you have to create a new account. So this is how accounts works in Solana. So you've got Solana network, you create a smart contract, and that is just a stateless smart contract. When I say stateless, it's a fancy way of saying that this smart contract does not contain any data. If it needs to manipulate data, let's say it has to say 1 plus 1 equals to 2, then that 1 plus 1 should be sourced to this smart contract, and that sourcing is done by another account. So as I said, everything is an account in Solana. Okay, you can think of accounts as a little cloud of data that stores information for you in the blockchain. You can have one super giant account that stores all the information that you need, or you can have many little accounts that store more granular information. So this is how it looks. We're going to create a tweet account for ourselves, for our program. We will have users that are also accounts. The program, the smart contract that we're going to write, and that will be an account as well. However, that will be an executable account. So with this understanding, let's try and understand how do we want to define our tweet account. So the way I think it, we could store all our accounts in two ways. Solution one is that we have one giant account storing all the tweets that will ever be created, right? However, the problem is that this solution won't be very scalable because we need to allocate a fixed size for our account when we create it on Solana blockchain. That means that we would need to define a maximum number of tweets allowed to be published by everyone. And obviously we cannot change this because blockchains are immutable. So once we deploy this smart contract, for example, saying we will have 10 million tweets. And tomorrow, if our application goes big and we have more than 10 million tweets, then we cannot scale it. So we cannot change the size of our account, right? So that is one problem. Additionally, someone has to pay for the storage that will exist on the blockchain. If we have to pre-allocate the storage for every single tweet, we will end up paying for everybody's storage, of course, and that would be a lot of money, and we don't want to do that. A better solution would be to have every tweet stored on its own account. That way, storage will be created and paid on the demand by the author of the tweet, of course. And since each tweet will require only a small amount of space, the storage will be more affordable and will be scalable for an unlimited amount of tweets and users. And I think this is the approach that we're going to follow as well. We will start by defining a struct. So we'll say public on Solana, like this. You could go with any name. I'm going to go with tweet on Solana. And if you think about what all details do we need in this struct or in this class, if you may, well, the first thing that we need is the author, or who is sending this tweet. So who owns this tweet, right? It could be you, it could be me, it could be Elon Musk, anyone. Okay. Then we need to know when was this tweet created. So we need a timestamp, and this will be of integer type. Then we also need to know the topic. This will be of string type. Last but not least, we need to know the content of the tweet. The content will also be of string type. Okay. Perfect. The one thing we also need to do in order to use this struct within Solana blockchain is we need to define our struct as an account, and that we can do super easily because we are using Anchor, like this. So this line number 17, where you see account, this line is a custom Rust attribute provided by Anchor framework. It removes a huge amount of boilerplate for us when it comes to defining accounts, right? Such as passing the account to and from an array of bytes, right? And thanks to Anchor, we don't need to know much more than that. And so let's be grateful for that, okay? Then we have publish struct tweet on Solana. So this is a Rust struct that defines the property of our tweet. You can think of this as classes that only defines property but without any methods, okay? And author we already discussed, timestamp, topic, and content. Perfect. The one thing that I think is important is to understand why do we need author here. So let's go back to the drawing board. Now you might think that creating an account on Solana blockchain keeps track of its owner, and you would be right. But then why do we need to keep track of Twitter's author inside the account data? Well, that is because the owner of an account will be the program that generates it. And let's try and understand that with the small architecture. So here is our Solana Twitter program. So this is our smart contract that we're going to write. Solana smart contract will own all the tweets that we're going to publish. Okay. Each of the tweet will have a public key reference for the users who have created these tweets. Okay. And there's a difference here, and this is important to understand that the purple one, or let's say the pink one, is our smart contract that owns the tweets. However, each tweet will have a reference of each user so that we are able to know which user tweeted which tweet, right? So we need to know which tweet is coming from Elon Musk, which tweet belongs to me, and which tweet belongs to you. And overall, there's a system program, and you can think of it as a super program that owns everything on Solana blockchain. So it owns our smart contract, and it also owns all the users. And I just want to go back to this slide, and you should try and understand that everything is an account, right? So tweet is an account, user is an account, our smart contract is an account, and all the accounts are owned by our system program. So that's, let's say, the father of all the accounts on Solana blockchain. Perfect. Now, since we understand why we need author's public key, the one thing that we also need to understand is the incentive to store less data on Solana. What this means is this. Okay, now that we know that what we want to store on our tweet account, we need to define the total size of our account in bytes. Well, technically, we don't need to provide an optimal size to store our data, right? We could simply tell Solana that, hey, we want our tweet account to be, let's say, 5,000 bytes or 5 kilobytes, and that should be okay. But in general, we don't do that because Solana gives us an incentive to not do that. And what is that incentive? Well, that incentive is rent. So here is how it works. User says, hey, can I create a new tweet on Solana blockchain? Solana says, so sure, why not? But I would need you to put some money in the bucket. The user says, sure, okay, go for it. And every so often, the Solana blockchain collects some of the money as a rent, and the rent is proportional to the size of the account. Which means that the next time when Solana tries to collect the rent, and if there is no rent, Solana will just delete the tweet or the account that you created. And you might think, wait, what? My data will be deleted? Yes, that is true. Your data will be deleted. However, Solana also provides a very beautiful way of preventing this, and that is called rent exempt. So what this concept means is that instead of paying monthly rent, you can actually put little bit extra amount of money in the bucket, and Solana will never collect rent from this account, which means that this tweet that you're going to post on the blockchain will live there forever, and this money that you put as a security deposit will also stay intact on the Solana blockchain. The incentive of doing this is that in case tomorrow you want to delete your tweet, all the money that you put in the bucket will be reversed and given back to you. This way, you can be 100% sure that you don't have to pay rent every so often, and whenever you delete your account, you're gonna get your money back. So that is just the nuances of Solana and how it works in terms of collecting the rent. And I hope that's understood and comfortable. Now we can move forward to start sizing our accounts. And in Solana, it's actually easy to figure out how much rent it's gonna use. So what you can do, you can go to your terminal. You can use Solana CLI. So Solana rent. Then you can just pass the amount of bytes that you want to store on Solana blockchain, and it will tell you how much Solana does it need. So here it is, rent byte per year, per epoch, and the minimum rent needed for the exemption. Okay. With that understanding, now let's try and understand the size of our account. So earlier we defined our tweet account with the following properties. We have author, timestamp, topic, and content. Therefore, to size our account, we need to figure out how much bytes each of these properties require and sum it up. Okay. So whenever a new account is created, a discriminator of exactly 8 bytes will be added to the very beginning of the data. That discriminator stores the type of account it's gonna be. This way, if we have multiple types of accounts, say tweet account, user profile account, then our program can differentiate between them. Okay. Alright, now let's size our author. So author in Solana is 32 bytes. Therefore, our author is gonna take 32 bytes in the memory like this. Then comes the timestamp. Well, timestamp property is of I64. That means it's an integer of 64 bits or 8 bytes. So we're gonna add that. There you go. Now comes the topic. A topic property is a bit more tricky because we have defined our topic as a string, and the string is a struct that defines a vector. A vector is like an array whose total length is unknown at the time of compilation. That's actually very nice, but how do we figure out its storage if we have no limit? Well, that depends on what we intend to store in that string, right? We need to explicitly figure out what we want to store and what is the maximum amount of bytes that it requires. Therefore, in our case, we are storing a topic, and that topic could be, for example, Solana, blockchain, and things like that. So it makes sense that we decided to have a maximum of 50 characters for our topic. And since we know that all the characters are UTF-8 encoded, which means that each of the character will take 4 bytes. Therefore, we will need 50 multiplied by 4, 200 bytes in the memory, like this. Okay. It is important to note that the size is purely indicative since vectors don't have a limit, right? So while we are allocating 200 bytes, typing Solana as a topic would only require 6 into 4, 24 bytes, like this. Which also means that there will be an unused area from our conceptualization, right? Therefore, before actually storing the content of our string, there will be a 4 bytes prefix whose entire purpose is just to store the total length of our string variable. Not the maximum length that it could store, but the actual length of the string based on its content. And it will be called vector prefix basically. So like this. And same goes for our content, which basically means that we will eventually have 1376 bytes stored in the memory. And basically we have to pay rent for this much amount of memory for each tweet that we're going to tweet using our Solana blockchain. Okay, beautiful. And just a reminder, your tweet account could look something like this, my topic, and that will only take these many bytes. And then we have a vector prefix which says this is my Twitter on Solana, and that's our content. So you need not necessarily be using all the bytes allocated, but that's the maximum counts to be able to capture. Okay, there are a couple of variables that we need. So for example, the first thing that we need is discriminator. So these are some useful constants that we need in our program in order to be able to size our tweet account. Okay, perfect. Last but not least, let's give a method on our tweet on Solana Struct so that it's able to calculate the length. And that is simple enough. So we'll say implement tweet on Solana. So this is the struct we want to implement. And here we want to have another constant length, which will be of type usize. And the value will be basically sum of all these constants like this. Perfect. Alright, so as we discussed that programs are actually special accounts that own their own code but cannot store any other information into it. And in Solana's term, we say that programs in Solana are stateless. And because of that, sending an instruction to a program requires providing all the necessary context it needs in order to run successfully. To do that, what we will do is we're going to create something like this, and then we're going to fill it in step by step so that we know what we are doing and why we are doing. Okay, so we're going to call it send tweet. Okay, and this needs to have info. I'm going to talk about everything in a moment, and then we'll say pub tweet on Solana like that. Then we'll say pub sender of tweet. This needs to be a signer. Then we will say pub system program. This needs to be a special kind, and that would be program, of course, info and system like that. Okay, now let's talk about what we have done and why we have done. What we are saying is that in this context, we're gonna create a new sender tweet. Okay, and that sender tweet will have a lifetime call info. And info is just the Rust lifetime. So I highly recommend that you watch the video that's coming on the top right corner. That will give you everything you need to know in order to understand the Rust concept. But in general, you actually don't need to know anything about these details. Just for your information, you need to understand that this is a Rust lifetime. It is defined as a generic type, but it is also not a type. Okay, its purpose is to tell Rust compiler how long a variable is gonna live in the memory. That's it. Okay, so that's all we are saying. Perfect. So that's step one. Then what we have defined is we have defined my tweet, and this my tweet should be of type this that we created, tweet on Solana. However, when we send this my tweet on Solana blockchain, it needs to be wrapped with a special kind of account, and that should be an account. Okay, because as we know, everything on Solana is an account. Okay, so we are wrapping our tweet on Solana into an account. Okay, much like the way we do the inheritance in any other programming language, giving a parent class and a child class. Okay, then we have got sender of the tweet, and this we need because we need to know who is sending this tweet, and we need their signature to prove that they are indeed the people or the person who is sending this tweet. Okay, last but not least, we have system program, and this is an official system program from Solana. Perfect. And honestly speaking, you actually don't need to dig deeper into the Rust features to find Now since we have defined our send tweet, we need to put down a couple of constraints. What we're gonna do is we're gonna do something like this. We're gonna say account, and this takes some parameters, so we're gonna say init, which means that we are saying, hey, please initialize this account, and this account will be initialized according to this. You should realize that the moment you initialize this account, someone has to pay for it, right? And that payment should come from, well, the sender of the tweet, like this. We also need to tell Solana that how much space it's going to take on the memory, and that will come from tweet on Solana len, like this. Okay, perfect. Now the compiler is complaining that the pair should be mutable, which means that we're gonna change the value, or let's say balance of Solana that this sender has. And since we want to change the value, we want to mutate the value in their account. Therefore, this account needs to be mutable, and we can do this by just saying like this. Lovely. Now, since we have defined our tweet struct, now let's use it. Now send some instructions to the blockchain. So what we're going to do, we're going to define a function. So we'll say pub function. Now this function could be of any name. So I'm going to just say send tweet, like this. Then inside this function, we need to provide a variable which should take the context. Okay, so we're going to say send tweet context, and this will be of type context, like this, and this will have sender tweet as an input. Okay, then we need topic, right? And that should be of string type, of course, and then we need tweet content, and then that would also be of string type. And at the end, this function will return a result if things are okay or not okay, like this. And at the moment, we're just gonna say okay. So we are saying everything is okay, so that compiler is happy and he's not complaining about anything. Perfect. Once we have that, we need to get a couple of things sorted. So number one is that we need to get my tweet account out of this context. So we're gonna say let my tweet, right, equal to end tweet context. This will have an account, and within the accounts we will have my tweets, like this. Now, as I mentioned earlier, that this my tweet account will be of type tweet on Solana, and this will be initialized because we have given instructions to initialize it. However, it will not have these details into it. Okay, and therefore we would need to manipulate the data within my tweet. And whenever we want to, mutate the data of a variable, we always make it mutable, like this, so that compiler knows that we're gonna change the value into this. Okay, that's step one. Perfect. Now we're gonna say send. We're gonna say let sender of tweet, and that will be equals to, you guessed it, send tweet context dot accounts dot sender of the tweet, like this. At this point, we want to just read it, so we're gonna say just give me the address of that tweet. Yeah, perfect. And then since we have timestamp, we would need to understand when this tweet was sent. So we're gonna say let clock equals to, and this will be clock get, and then we're just gonna unwrap it. What unwrap does is it will figure out the clock type out of this get function, and if an error occurs, it's gonna just raise that exception, if you may, and the program will stop. What this means is that if we are not able to get the clock instance, the program is gonna stop. Okay, so that's all unwrap does. Perfect. Now let's fill in my tweet. So we're gonna say my tweet dot author. So author is sender of tweet, right, dot key. So whatever key sender of tweet has, that will become author. And since we don't want the address, we want to read the value of that particular location in the memory, we're gonna say star, like that. Then we will say my tweet dot timestamp, and that should be equals to clock dot Unix timestamp, like this. What else we want to fill? Well, we want to fill the topic, right? And that should be simple enough, topic. And then we'll say my tweet dot content. Well, that should be equals to tweet content variable, like beautiful. Believe it or not, right now we are done with our Solana blockchain smart contract. However, if someone sends a topic which is, let's say, a length of 1000 characters, in that case we have not defined anything to safeguard our program from that. And the worst scenario is that the topic is super long and eventually the author, the sender of the tweet, has to pay rent for that topic. Since we don't want that, we would like to create a couple of test cases. So we're gonna go here. Before we do anything, we're gonna do two tests. We're gonna say if topic dot characters dot count. If this count is greater than 50, this is what we defined here in our constants. If the count is greater than 50, well, then we want to throw an error. And we want to test another one. We're going to say tweet content, same thing, characters dot count. If this is greater than 280, well, throw an error. So in general, the best practice of throwing an error is we create an enum and then we just use that enum to throw an error. And in Anchor, it's super simple. What we can do is we can say pub enum, let's say tweet errors, and then we can define our own errors. We're gonna say topic too long and content too long, like this. Wouldn't it be great if we have a custom message for each topic? Well, thanks to Anchor, we can also do that. So we're gonna use the attribute message. And within the message, we're going to say, last but not least, we need a decorator, if you may. So we're going to say error code, like this. Now, this enum is of error type because we have given this attribute to this particular enum. All we need to do is we need to just go and return this error. So we're going to say return error. We're going to use the error macro. And within this macro, we're going to say tweet, and the error would be topic too long, like this. Copy that, paste it here, and this time content is too long. Beautiful. And ladies and gentlemen, we have actually finished whatever we wanted to write in the contract or in the Solana program. Now is the time that we go and test our program if everything is working the way it should be working, okay? We want to go to our terminal, and within the terminal, we want to build the program, right? And once the program is built, we want to deploy it to the Solana blockchain. What this means is that now our program, so this particular program that we have written in Rust, is deployed to Solana blockchain, and to read, or let's say to get data from this program, or let's say to execute this function, all we need to do is we need to somehow go to Solana blockchain and ask Solana blockchain to give us the program that is residing at this particular address, okay? And this address is the same that we did a moment ago. Perfect. With that understanding, we're gonna close this folder. We're gonna go to test folder, go into Solana tweets. All right. So in order to write test cases, or let's say to interact with Solana, we actually need to understand how Solana is designed and how it is structured. Okay. So the first thing that we need to understand is this, that we have a Solana cluster, and this could be anything. It could be localhost, it could be dev, it could be anything. It could also be mainnet, and that cluster is actually encapsulated by connection. What I mean by that is we will create a connection variable that will be responsible for talking to the Solana cluster. Okay, so that's step one. Then, as we discussed, that whenever we want to create anything on Solana blockchain, which is this, which someone has to pay for it, right? So it has to come from someone's wallet. Now, the connection variable is able to understand what's happening in the cluster in the Solana blockchain, but it does not understand how to collect money, right, from the wallet. So there's a disconnect. Therefore, we need a provider. Now, provider is, let's say, another class or a variable that will be able to bridge connection and wallet. So it basically will take money, deduct money from our wallet, and it will be able to send instructions to the Solana blockchain. Okay. Adding a little bit more complexity is that, so we understood this part. However, in reality, what we just did is we built our anchor program and we deployed it. So when we deployed our program, it went to the cluster for sure, but it also generates an IDL for that program. An IDL is basically like a blueprint that explains what is written in our smart contract using Anchor. So what we do is we create a program variable. Now what program variable does, it basically is able to understand what is written in our smart contract, and it's also able to understand everything that the provider does. And what does the provider do? Well, provider is able to talk to connection, and connection is able to talk to the Solana cluster, and provider is also able to talk to our wallet so that it can deduct or add money to our wallet whenever we want to post a new tweet on the Solana blockchain. Therefore, the program variable becomes super critical. And just a recap, it can talk to our smart contracts, it understands how the smart contract is designed, and it's also able to talk to the blockchain. Okay. Last but not least, we just discussed this amount. There's another variable that comes into the picture, and that is anchor. Now, if you notice, and if you go to your anchor.toml, you will find that currently it is configured to talk to a cluster that is running on localhost. However, you will see that we're going to change this setting when we design our front end using Next.js application. We're going to change it to Devnet, and that configuration is actually sourced from anchor.toml, and it also provides kind of a variable, or let's say environment, from this TML so that we can source this to our provider. And conceptually, if you want to try and understand, this is important because provider needs to know from which wallet do we need to deduct money and to which cluster are we talking to. Therefore, these two should be compatible, and therefore we need that from the environment variable. Perfect. And I think with that understanding now, we should be able to design our test cases. I have deleted everything that I had. We just have one describe, which is this. Now within this describe, now you should know that once we have deployed the program on Solana blockchain, we want to interact with Solana blockchain using a front-end feature. For example, clicking a button and then doing things, right? And to do that, we can use different frameworks, for example, Next.js or React. We're going to do that in a moment. But for now, we want to use JavaScript, pure JavaScript, and then we want to interact with the Solana blockchain network using JavaScript. And if you understand this part, I think it's super easy to take this concept and build it into your application. Okay. So let's see how we can do that. We can say we're going to create our own test. We're going to say it can and the new tweet, right? It's going to be a asynchronous task, and then we need an anonymous function on it, and there you go. Now within this test case, we would like to define a couple of things. The first thing that we want to do, we want to create a new program on the Solana blockchain, or let's say new account on Solana blockchain. So we're going to say const tweet key pair. This could be anything, any name that you like, but we're just gonna say tweet key pair anchor.web3.keyPair.generate. What this will do is this will create a new key pair on Solana blockchain, and we will have the public key and private key of that new key pair in this variable. Okay. Once we have that, we're going to write a couple of test cases on top of it. Okay. So we will say, and before we move forward, we want to define two more variables. So let's super quickly do that. Anchor.setProvider. We want to point anchor to a provider, and that provider would be anchor.provider. We are telling to the anchor that set a provider and use the provider that is already defined in the environment variable. Okay. Once we do that, we want to initialize another variable. We will call it program. And that would be anchor.workspace, like this. What we are saying is that create a program variable, and that should be taken from the Solana Twitter workspace, which is basically this folder that we created, and that should be of program type. Okay. Now we can write our test cases. So we will say await program.methods, and this method should have send tweet method on it. One thing to notice is that the send tweet method is actually equivalent to this one. However, in Rust, we write functions in snake cases, but the Web3 package of the front end basically converts that snake case into camel case. Okay. So we're going to say send tweet, and this should take two variables, topic and tweet content. So we're just going to simply provide that. We're going to say my, then we want to say account. We want to provide all the accounts that this function needs in order to run data on the blockchain. Now, if we go back to our function, the way we have defined the context, we need only one context, which is send a tweet, and send a tweet basically needs these three accounts. Okay, so now let's super quickly create that. So we will say my tweet, that will be tweet key pair.public key, like this. Again, one thing to notice is that my tweet is actually equivalent to my underscore tweet, because this is snake case and Web3 interface basically converts it into camel case. Okay. So we have provided a new key pair, or let's say a new account that was brand new and created right here on the blockchain. Okay. The second item that we need to send as a context is sender of the tweet, right? And this will be whoever is running this program. So we will say provider.public key, like this. Which basically means is that we have, if you go back here, we already have a key pair wallet, right? We have our wallet details sitting right here. And this is what we are saying in our test, that, hey, we created a program variable that is sitting in this particular folder. From this program, please pick the public key of this particular wallet. Okay. Last but not least, we need to provide system program, and that should be super simple. We're going to say anchor.web3.systemprogram.program ID, like this. And this should provide us the system program ID, so that we are 100% sure we are sending the correct program ID. What else do we want to send to this send tweet method? Well, accounts is okay. We also need to send the signer, because we need to know who's going to pay. So let's send the signer as well. So we're going to say dot signers. Now this will be a list of accounts, but in our case it's just one account. So we're just going to say tweet key pair. So this account is going to pay for the creation of this tweet. Okay. I want to talk about what is RPC in a moment. What this will do is this await keyword will send an instruction, okay, to the blockchain to basically execute everything that is in this function. And we have provided all the accounts, signer and RPC. At this point, we are waiting and assuming that everything should be executed on the blockchain. So once that is done, what we're going to do is we're going to try and retrieve this data. Okay, how do we do that? Well, we'll say const tweet account equals to await. Everything is asynchronous. Gonna say program dot account dot tweet on Solana dot fetch. Okay, so once we created this tweet on account on the blockchain, it gives us a function that is fetch function, and within the fetch function we could actually provide a public key, and with that public key we should be able to get the account whichever is associated to that public key. Okay, we're gonna say tweet key pair dot public key, and then we're just gonna say console dot log account like this. The first thing that we did, we set the provider, which is localhost as of now. So our blockchain is localhost. Then we created a program variable so that we can interact with the blockchain. Pure JavaScript, nothing to do with blockchain. Then we are saying, using the Anchor framework, Web3, please create a new account. And this tweet key pair will now contain a public and private key. Okay. Then we are saying that on the program there is a methods which we created send tweet, and that takes two parameters, topic and tweet content itself. And then in order to execute this tweet, in order to put this on the blockchain, we need to know a couple of accounts. Number one is of course the tweet account itself. So basically the account that we created, its public key will be used to create the tweet. Okay. Then we are saying that who is sending this instruction, so who's gonna pay for it. Then we create our system program, which is fine. Then we need a signer, which basically means is that we want to create a new account on blockchain and someone has to sign that, so that we are 100% sure that whoever owns this public key should also owns the private key for this. Therefore, we're going to just pass that signer here, and we are assuming that with this instruction there should be a new tweet on the blockchain, and the public address, or let's say the unique ID to get that account, is tweet key pairs public key. Okay, so now this public key should have the text that we provided. Okay, and go back to our console. Now we're going to test if everything works. Okay, so we have already deployed our smart contract, so it should be able to read it. Now we're going to say anchor run test. Lovely. As you can see that with our public key we were able to pull out our tweet, and our tweet topic was GKV's tweet, and the content was my first tweet. Amazing, right? I mean, obviously everything passed because we did not put any assert statement here. We are not checking anything. We are just saying if things happen, then just consider it to be passed. Okay, perfect. Now let's put some conditions to check that whatever we have designed here is working the way it should. Okay. Alright, now it's the time to put some real test on our test cases. So we're going to delete the console log. First thing that we want to do is we want to import something. So we're going to say import star as assert from assert like this. Okay, now we can use assert to basically check if things are okay or not. Assert dot equals, we want to check if what we are expecting and what we are getting are equal or not. So we're going to say tweet account, so whatever we were able to fetch from the blockchain, dot author dot to base 58 is equals to program dot provider dot public key to base 58 like this. What we are essentially saying is that whenever we get an address from blockchain that looks something like this, like a hash, and from this hash which is of base 58, we want to convert that to string. So this assertion will ensure that the author of newly created account matches the public key of our wallet. Then we want to check assert dot equal, we want to check tweet account dot topic is actually equals to the topic that we shared. So we'll say GKV's tweet, exactly what we sent. Similarly, we would like to check and we would like to check if there is a timestamp. Okay, so we'll say assert.okay, which basically checks if things are true or false. So we just want to say if timestamp exists on our tweet. Okay, beautiful. Now let's go back. We just wanna say anchor run test. Everything should work fine. It's able to send a new tweet. Lovely. Now let's try and write a couple of more tests, because writing tests will basically reinforce your understanding about how the Web3 and the blockchain interact. Okay, we're gonna write another test. I'm gonna copy everything, paste it here. Now I will say can send a new tweet without a topic, like this. Everything stays the same. We're gonna delete this, and the tweet will be, I will like this video. Everything remains the same. I'm just gonna remove the topic, and my tweet is actually this. Perfect. Now let's go here and run the test. Hopefully 2 test passes, so we are able to tweet without the topic. Yay, I like it. So far what we have been doing is we were able to send a tweet from one particular account, which is basically the account that is associated with this anchor.tml. What if we want to send a tweet from a different account? How can we do that? Well, let's try and do that super quick. As you might notice that everything on blockchain Solana is an account, so we can basically say other user, right? And this will create a new account for the user, and this will create a new account for the tweet. Simple. Now, instead of saying that use my public key, I would say use other user's public key. And in the assertion, we want to compare this to the other user's public key, right? And here I will say I will subscribe to it's okay to be logical channel, because why not? And let's give it a topic. So we'll say like and subscribe. Copy and paste it here. Shall we run it? Okay, let's do this. One of the tests is failing. I wonder why. Let's see if the error is giving us some description. It's saying signature verification failed. Let's see what's happening. The problem is that we forgot to add other user as a signer, because if you're using other user's account to basically pay for Solana, that user needs to sign this particular transaction, right? Okay, perfect. So let's go back and run it again. I hope this works. For a different type of error, it's saying fail to send transaction simulation failed, error processing this, custom error. Seems like we are still missing something. So let's see what else can we do. And if you're able to figure out, really awesome. If not, let me explain. So what's happening here is that we are saying that, hey, this is my different user, DIFFE, a different user, and we just created this user out of the thin air, right? So this is a new user account. However, this user doesn't have any money, right? So it doesn't have any Solana in his wallet. And what we are saying that this other user is now the sender of the tweet. Therefore, this user needs to pay for the rent. And since this user does not have any Solana, well, our transaction fails, okay? What we can do? Well, what we could do is we could do something like this. So before running the test, we could say await program dot provider dot connection dot request airdrop, and we'll say other user dot public key. So this is the address where we want to send some Solana. How many Solanas? Well, 1,000,000,000,000,000. technically 1 billion lamp ports, and this is how many lamp ports we are sending to this public key, right? Perfect. However, there's just one problem. If we do this and move on, probably it will not be enough time to credit this user with these many Solana, so basically 1 Solana. And fortunately for that, we have another function which will confirm that if this has the money that we requested. So we're going to say const signature equals to this confirm transaction, which needs a couple of items. So let's create those. We're going to say const latest block hash is equals to await program dot provider dot connection dot get latest block hash, like this. And then with using this variable, we could fill in all the details that this function needs. So we'll say block hash is dot block hash, like this. So this is the latest block that was added to the blockchain. Therefore, we got the hash out of it. And we'll say last valid block height. Well, we could get that from latest block hash dot last valid block height, like this. Last but not least, we need to know the signature. So that is simple. That should come from our variable signature. By adding this, we make sure that the 1 Solana that we send to our new user, that is credited to their account, and now they should be ready to make this transaction. Okay. Since we are writing the test cases, we need to manually do all these checks that if the user has the money or not. In the real life scenario, you normally use a wallet, for example, Phantom wallet, and that wallet is already responsible for signing all the transactions that we are doing on the blockchain. Okay, perfect. So now let's go here and try and run our test again. And all the test passes because now our user has Solana. Okay, beautiful. At this moment, you should have really good understanding of how blockchain works and how we can interact with the blockchain using the front-end tools, for example, JavaScript, React framework, Next.js framework. However, I just want to write one more test so that we are able to test if the custom checks that we wrote are working the way it should. Okay, so what I'm going to do, I'm going to go up here and super quickly I'm going to copy this, paste it here, and I'll say everything stays the same. Now the topic could be const topic too long, and that could be anything, right? So we'll say, and then I just gonna say repeat it, I don't know, 51 times. This is definitely more than 50 characters, so this test should fail, right? So I'm gonna copy here and we'll say this is my long topic. Now the question is, how do we test if this restrictions were working? Because the moment you send this long topic, this test gonna fail, right? So if I go here and try and test this, you see that one test failed, but we would like to have it in other way around. We would like to say this is passed, but we were not able to send a topic of more than 50 characters. To do that, what we will do is we're going to say try, and then we're going to say catch. Now cut everything, paste it within try block. So now we're going to say is please try and send this tweet. Okay, topic is too long, content is I'm going to like this video, and then so if an error occurred, we're going to say assert okay, that yes, we were able to go into the error function, therefore this statement was not successful, and we'll say it failed, hence test passed. Okay, now go here and run it and see again if it works. Perfect, so everything works the way it should. Alright, so far we have been writing tweets to our blockchain. Now let's write a couple of tests to actually fetch the tweet that we have written on the blockchain. So this test we're gonna say can fetch all tweets, right? And all we want is a constant, so we're gonna say tweet accounts actually equals to await program dot account dot tweet on Solana, of course, all. And this should fetch everything for us from the blockchain. We'll just log it to the console. Okay, going back and anchor run test, and here you go, we've got all our tweets. So GKV's first tweet, my first tweet, we will like this video, we'll subscribe to the channel, like the video without the topic, and this is our first tweet. And the one thing that I want to point out is we have same kind of tweet multiple times. That is because our test validator keeps on running, right? So when it keeps on running, it just append the data to the blockchain. And if we want to clear all the data, what we can do is we can Control C, so we can close this. What we can do is we can say Solana test validator reset. So this will reset our blockchain. And now instead of saying anchor run test, which only executes the test script, we can say anchor test. What this will do, this will build our program, it will deploy it on the blockchain, and then it will run the test for us. Now we can see that we only have limited tweets. So we have like and subscribe, we have a tweet without the topic, and then this is our first tweet. So we have got 1, 2, and 3 tweets. Okay, and 5 of our tests are passing. Perfect. Now let's see if we can fetch data using the author. So for example, I only want to fetch tweets tweeted by Elon Musk, for example. Well, in order to fetch all the tweets, we first need to understand one concept. Alright, now let's try and understand how can we filter tweets from our Solana blockchain. So if we look at this gray area, which basically is the whole Solana world, within this Solana world, there will be many different apps. So one of them is of course our Twitter app, there will be another app, and people will be creating different apps, which is fine. Now whenever we say fetch all, it basically goes to Twitter account that we created, and then it fetch all the tweets that was ever created on this Twitter account, right? So it's gonna fetch everything for us. Now in order to make a filter on our search term, we can use 2 different types of filter. The first filter is data size, which is not very useful for us, and the filter that we want to apply is called MEMCMP, which means mem size. What that means is we need to go back to this window. Now what we will tell to the filter that, hey, when you pick one account, so whenever you are searching the account within the Twitter account, so coming back to this, when you're looking at each tweet that you want to send back as a fetch result, do an offset on it. So basically go until here and then compare the author's public key that we're going to provide as an input, and whenever that author's public key matches with the key that we're going to send in each of the tweet, only return those tweets. And this is how we can filter Twitter account based on the author's public key. Now you should understand that if we can do this, we can technically also do an offset until here, and then we can filter on the exact topic as well, or we could do an offset until here, and then you can filter on exact content as well. Okay, unfortunately on Solana as of now you cannot do greater than or equals to, less than or equals to comparison. You can only do equals to comparison, but this equals to comparison is good enough for our use case, so we're going to use that. Okay, now since we understand the concept of memory and memcmp, now let's see how we can filter tweets by author. So we can say can filter tweets by author. We're gonna say const author public key is equals to program dot provider dot public key, like this. And as you notice that we have used this public key earlier to send some tweets on the blockchain. Okay, we should have 2 tweets with this account and 1 from the other user, this one. Okay, now let's see how we can write that test. So we're going to say author is here, which is good. Now we're going to say const, that should be equal to await program dot account dot tweets on Solana, right? All, so we want to fetch all of those. However, we want to provide few constants. That would be, we want to have memcmp, and then we want to say offset. How many bytes do we want to offset? Well, we want to offset by 8, which is basically, then bytes would be author.public key dot to base 58, of course, well, like that. And this is how we should get all the tweet accounts. And then we can go here and say assert dot equal, how many accounts should we have? Well, we should have 2 tweets, right? Now let's see if this works. I'm gonna go here and we're gonna say anchor test, build, deploy, and it's able to filter by author as well. Lovely. With this understanding, now you should be able to understand that if we are able to do this using JavaScript, we should be able to design an HTML page. On that page, we should be able to design a button, and with a click of that button, we should be able to fetch everything from the blockchain. And the way, for example, we are saying console log tweet accounts, and then we get all these details. We could technically just use this account to basically show something beautiful on the website. Now that we are comfortable with our test cases, what we're gonna do is we're gonna install Next.js within our app so that we are able to design a beautiful front end. Okay. And to do that, what we're gonna do is we're gonna go to the Google and we're gonna search for Next.js installation with TypeScript. Okay. Then we're gonna open this link and we're gonna copy this command. Then we're gonna go back to this folder. Within this folder, we're gonna right click and open it in terminal. Then we're gonna paste this command. Gonna ask for a name of the project. It doesn't matter what you give. So I'm gonna just say test. Once we have everything installed, what we're gonna do is we're gonna go back to our folder, go inside the test, Control A, cut everything, and paste it back to the app folder. Then we're gonna delete the test. Okay, perfect. Now we're gonna go back to our Visual Code, and now within the app, you should have everything that you need in order to get the next project started. And to test if every installation was correct, what we're gonna do is we're gonna go to the terminal, open a new terminal. Then we're gonna say cd app, and within the app we're gonna say npm run dev. This should spin up a new localhost server for us. So if we go back to our browser and I type localhost 3000, we should be able to see something like this. And if you see something like this, then you've done a great job because you have installed Next.js the way it should. Okay. So once we have Next.js installed, we need a couple of dependencies that Next.js need in order to be able to talk to the Solana blockchain. For that, we're gonna go to the GitHub Solana Labs wallet adapter. And if you scroll down, we need to install all these packages. So I'm gonna copy this, open a notepad, paste it here. And then we need, the command we need is npm install -- save, because we want to save all these dependencies in our package manager. Come back here, open a new terminal, cd apps, and then I'm going to just paste it and press enter. This will install all the dependencies for us, and while it's installing all the dependencies, when we design our app, we want to make it a little bit more beautiful, and for that we're going to use Bootstrap 5. So that's how we're going to use it. I'm going to go here, go for the latest version, go to home, and within home it should give you a command to install Bootstrap. I'm going to copy this, paste it in our notepad. Then I also want Bootstrap icons. I'm going to click here and simply copy this. So our command is npm install. I is short for install, and then we're going to say -- save. Go back to our Visual Studio Code, and once everything is installed, I'm going to say paste it here and press enter. This will also install Bootstrap for us, and now we are ready to start developing our Twitter app on the Next.js platform using Solana blockchain. Alright, so we have installed all the dependencies that we needed in order to get our next project started. However, we also need to do one more thing, and that is we need to go to anchor.uml, and here instead of saying localnet, we're going to say Devnet, and this will also be Devnet like this. So once we save this, we need to go to our terminal, and here we need to deploy our anchor project to the Solana blockchain dev network. Okay, how do we do that? We'll say anchor build, and we will say anchor deploy. And with this, we should be able to copy this program ID, go to explorer.solana.com, change network from mainnet to devnet, and then we should be able to search with this hash block, and we should be able to see that our program is now deployed on the dev network. Okay, so once we have done this, we're going to close this. And we're going to go to our app. Within app, we're going to open pages, and within pages, we're going to go to index, right click and delete this file. And then within pages, we're going to go back, create a new file, we call it index.tsx, because we want to design index in our way, the way we like it. So here we're going to say const index page equals to, like this, save it, go back to our localhost. If we refresh the page, we should get I am from index. Perfect. And now we have a clean slate, and from here we want to redefine our project. So for that, we're going to go back to Bootstrap, we're going to go to documents, we're going to scroll down to component, and we're going to go to navbar. Within navbar, what we're going to do, we want to look for responsive behavior, and we're going to copy everything that we have here because we want a navbar that looks something like this. So we're going to go back to pages, we're going to go back to app, right click, create a new folder, we call it components. And within components, we're going to create a new file, and we're going to call it navbar.tsx like this. And here we're going to say const navbar. We're going to say return. We're going to return everything that we copied, and then we're going to say export default navbar like this, and we're going to replace class with class name. Okay. Last but not least, we do not need this form, so we're going to delete this, save it, and in the index page, we're going to just call this navbar. Okay. I'm going to save it. Now if we go back to our localhost, we see home and hidden, but it does not look beautiful, and that is because we have not included Bootstrap, JavaScript and CSS into our app. So what we're going to do, we're going to go to app, and here we're going to include two things. Now if we go back, refresh the page, now we have a good looking nav bar, right? Perfect. Now let's make a couple of changes in our nav bar. What we want the nav bar to be of dark theme. If we save it, now this is dark, perfect. And we want this to be of text light so that we can see things. Perfect. And within this, we're going to delete two of these. We don't need that. And we want this to be my tweet. This should also be text light. Perfect. At the end, we would like to have a button. And when we press on this button, we should be able to connect to our Solana wallet, right? So we'll say connect wallet like this. And we'll give it some classes. So type is definitely button. Class is button, and we'll say button primary. Perfect. This looks good. If we click on my tweet, this doesn't go anywhere. So there are a couple of things we need to change. Number one is that when we use Next framework, we never use anchor to navigate from one place to another. We normally go with link. A link should be imported from Next like this. And link takes one parameter, which is href, and whenever someone clicks on this, it should go to home page. So we can actually remove this. We don't need this. Similarly for this one, we're gonna say link. href should be slash my tweets, and we can remove this. Now if we click here, we're at the home page. Now if we click here, we're gonna go to the my tweets, but we're gonna get 404 error, and we also notice that the nav bar is gone. Well, that is because we do not have a layout for our app as of now. So let's fix that. What we're gonna do is we're gonna right click here, we're gonna call it layout.tsx.ts, and we'll say const. The first thing that layout should have is a nav bar, right? And layout will take some props. It will be of type any. Once we populate nav bar, we want to populate everything that comes as a children. So we're gonna say props.children like this. Last but not least, we would need to export this. So export default, and we're going to use layout in the app, and we're going to wrap everything with layout. So we're going to say layout like this, and everything should become child of this. So if we go back to our page, now we should have a nav bar for everything, and if we click here on the index page, we got two nav bars, and for my tweet we only have one nav bar. What this means is that on the index page we don't need this anymore, and we need to create another page, and that should be called my tweets.tsx, and this will be const, and as always we're going to export this. Perfect. So now everything should work. So this is from my tweets, so we can go to home page, and this is from index page. The one thing that is missing from our layout is that we need to change the name. Instead of saying hidden brand, we want to give it our name. So going to nav bar, and here we're gonna say Twitter on Solana. Lovely. And instead of having this button, we would like to have a button to connect with our Phantom wallet, which is here, right? So let's do that. So if we go back to the official documentation of Solana wallet adapter, they have provided us something like this, which we can use in order to connect to the wallet. So I'm going to copy everything. Within component, I'm going to create a new file, and I'm going to call it provider, and we'll say I just copy paste everything. There are a few things that we don't need, so I'm going to remove those. We don't need FC, React is automatically included. We did not install mobile adapter, so we don't need this. We don't need a C. Instead of calling it wallet, we're gonna call it Solana wallet provider. And same should be here. So we're gonna say export default this becomes constant. And within the wallets, we're gonna create a couple of new wallets like this. Okay. Now let's go through it quickly one by one. So we are saying that component called Solana wallet, and we create a network on Devnet. You can change it to testnet, mainnet, whatever you like. This creates an endpoint for us, and we also create a couple of wallets. Then Solana developers has provided us a couple of components that we need to use in order to create the wallet. And they're also saying that your app component should go here, which basically means is that we can, first thing first, we can remove these two. Okay. And instead of saying this, I'm going to say layout, and I'm going to say props. I'm going to say props.children like this. And then we would also take props as parameter. If we go back to our app, nothing should change because we are not using it. So in order to start using this component, technically this component instead of layout throughout our app, you should have guessed it by now. What we're going to do is going to copy this, go to app, and instead of wrapping everything with layout, we're going to wrap everything with Solana provider. So if we go back, everything should remain same because we technically did everything, but we're not using anything here. So the moment everything updates, it's going to ask us, the Phantom wallet is going to ask us that password. I'm going to just give my password. But we don't know if we are connected. So we don't have any means to see if we are connected or not. And that's where this button comes handy. Now we're going to go back to our layout. So where do we want that connection button? We want it in layout, but specifically we want it in the nav bar. So we're going to go into the nav bar. Now instead of having this dummy button, we could have something that is provided by Solana developers. So we're going to delete everything, and we're going to say wallet multi button like this. And this should be imported from wallet adapter React UI like this. Now if we go back to our app, we should see the button to connect to the app, which means that I could go and click on disconnect. Now I'm not connected. If I go here and click on select wallet, I should get this dialog box which has more options as well. So you can connect to multiple wallets. I have Phantom installed, so I'm going to use the Phantom, and hence I'm connected with my Phantom wallet. Lovely. You could go to Google, and here you could type explorer.solana like this to verify if your program is actually on the Solana blockchain, and press enter. And here you should see that my program is already deployed on the Solana blockchain. Okay. And I've got a couple of transactions, which means that I have sent 4 tweets on this blockchain, and we should be able to fetch these 4 tweets. Okay. So let's see how we can do that in our front end. Let's see how we can fetch all the tweets that is sitting on the blockchain. Now going back to the official documentation, they gave us this setup, which we have already done in order to connect to our wallet. Here they are giving us example usage, how to use this Web3 package in order to get data from the blockchain. Okay, so let's super quickly do that. I'm going to go back to VS Code, and here I'm going to create a new folder, and I will call it libs, the libraries. And here I'm going to create a new hook. We'll call it use wallet hook.tsx like this, and we'll say const. Now the reason we are creating this hook is because we want to return a couple of items from this hook, or let's say from this function. So whenever someone calls this function, they should be able to get a connection. They should be able to get a program and provider from this function, so that they are able to fetch data from the blockchain. much like what we created in our test cases when we were writing this command line Solana test. And if you remember, we created a program variable, right? And with the program variable, we were able to use methods. We were able to send tweets and accounts and whatnot. We want to do something similar. So let's see how we can do that. I'm going to close this. And here, the first thing that I want to say is I want to tell what all things this function will return. Okay. So the first thing that this function will return is connection. This connection will give us a lot of details. So we're going to check upon that in a moment. Then we want adapter wallet. So I'm going to just copy paste that super quick. And we're going to copy paste a couple of imports so that we know what we are importing and from where we are importing. If you go back to our Solana smart contract, we actually want to know how our accounts are structured, right? So which all values and keys does this tweet on Solana account has. In order to understand that, we need to help our program, and to help our program, we will import IDL. And this is very important because we need this in our program to know how did we design our anchor program, right? So which functions are there and how to use them. So we're going to say import. You can give any name you like. I'm just going to say IDL from, and I want to pick it from one folder up, then one folder up. And here there should be a folder called, oops, my mistake. Seems like I have created this folder in wrong directory. So I'm going to cut it. I'm going to paste it within app. Now things should be fine. And here we want to import our IDL. So I'll say import IDL from one folder up and then one folder up. And here I should have a folder called target. Within this folder I should have IDL. And there I should have my Solana Twitter.json. Perfect. So let's create another constant and we're going to call it program ID. And this program ID will be very simple. We're going to say new, and this should be idl.metadata.address. So from our IDL that we imported as a JSON, from there should be a metadata and we should have an address. And that address will technically be, if I can go here, that address will be this. Okay. Perfect. So we got our program ID, and now let's design this function. The first thing that we need is a connection, and to do that we will say const connection. So that's a variable, and we'll just use connection hook to get the connection. Now remember that this use connection is connected to our wallet provider, and it is able to fetch out the connection that we have. And from this connection, you could actually get account info, account balance, and lot of different details, right? Perfect. Let's keep it that way. Then we need an adapter wallet that provides a lot of information regarding whose wallet is connected and its public key and everything. Okay, so let's do that. So we're gonna say const adapter wallet object. We're gonna call it object, and we're gonna use another hook, and it's called use adapter wallet, like this. You should be able to see that it has auto connect, is user connected or not, public key, send transaction, lot of different useful functions and attributes. Okay. Now since we have these two, we should be good to go. However, now we need another adapter, because this adapter is Web3 adapter, and this adapter does not understand what is written on the Solana blockchain. Okay. So for that we need another adapter, and its name is anchor adapter. Very creative. We're gonna say anchor wallet object like this, and we're gonna use another hook, and it's called use anchor wallet. Perfect. Now since we have all the connections that we need, let's create a provider. And we need a provider because it is required by the program we're gonna create in a moment. Again, if I go back to our test, you remember we created a program, and this program will need a provider because it needs to know how to fetch data from the blockchain. Okay, so let's quickly create a provider. It's a new anchor provider like this, and this needs connection as an input, and it also needs adapter wallet. It also needs a confirmation option. We're going to provide an empty dictionary like this. We don't care about the type of confirmation. Even if it's pending, just give me the result. Okay, so we're going to keep it this way. And now we will create our program. So program will be new program, right? And this will take IDL, of course, as an input, because it needs to know how our accounts are structured. It needs to know the program ID, so which program to pick from the Solana blockchain, and the provider, because it needs to know how to connect to that. And that's it. Our job is done. So we're going to say return connection. We're going to return everything that we promised here. Probably won't need all of these, but we are just returning it for the sake of it, and we'll see if we need it or not. Okay, perfect. With this, our use wallet hook is complete, and what we could do is would actually just export this as a default. So we'll say export default use wallet hook. That should be good, and we're gonna close this. Perfect. Now since we have our hook, we can go to index page and we can start fetching all the awesome tweets that we have posted, right? So let's do that. We gonna go to index page, and here I'm gonna say const programs that should be equal to, should be coming from use wallet hook like this. And if you remember, we just created in the lib folder, so it's here. It returns multiple things, and I'm just cherry picking only the program here. Okay, now let's think about it. If we want to fetch all the tweets, right, how do we do that? Well, we would technically do it on use effect. We want to fetch all the tweets once this component is loaded, right? So I'm gonna just go here and say program dot account dot tweet on Solana. You know what, even before this, let's do one thing. We wanna just say log program, so that we can see what is there in the program, right? So let's try and understand what is there. What are we getting? If I go here, zoom in a little bit, we have got account, we got instruction, we got methods, RPC and whatnot. And if you go to account, you should see that I've got tweet on Solana, lovely. And on the tweet on Solana, I have got ideal account, and that has 4 types, and that has 4 fields: author, timestamp, topic, and content. And if you remember, this is what we have created in our anchor program, right? Perfect. Just close this, go back. Now all I want is I want to use accounts, and within the account I want to use tweets on Solana. One thing to notice is that when you start using programs, so I'm gonna say program.account, and if you put a dot, you won't get any suggestions, and that is because Anchor or Web3 has no way of knowing what did you create in your Anchor program, right? So you need to know this on your own. You need to know this by knowing the IDL of the program, okay? And you could actually figure out by printing it here and just see the account is called tweet on Solana, okay? Let's say tweet on Solana, and then we have multiple methods. I'm going to say all like this. This should give me all the tweets that is related to this program, okay? And this is an asynchronous function, which means that it's going to return a promise. So I'm going to say when that promise is resolved, then give me all the tweets, and we're going to write a function, and here I'm just going to log everything like this, okay? And then we'll see how we can use this data. So if we go back here, now I should have 4 tweets, and each tweet have a public key, of course. Then it has an account, it has an author, timestamp, and topics and whatnot. Beautiful. All we need to do right now is somehow we need to display this to the user. And whenever it comes to displaying things to the user, we always go back to Bootstrap. I've already thought about it, how I'm gonna display this. So if you go to component and if you go to card, each tweet will basically be a card. And I think this is the card I want to use because it has a title, subtitle, text, and some links, right? So I'm gonna just super quickly copy this. In my components folder, I'm gonna create a new file and I'm gonna call it tweet card.tsx like this. And you know the drill. And then we're gonna return. What do we return? Well, we return what we copied. And of course, we're gonna replace the class with class name. Beautiful. So save it. Now we go to index. There's one thing I also want to do is, as soon as we get all the data, we would like to, show it to the user, right? So how do we do that? If you have been following my next tutorial, you should know what to do. So the first thing that we want to create here is we want to create a state variable. So we're going to say const all tweets, set all tweets. We're going to use the state hook, and we'll initialize it as empty array. And what we are saying that as soon as we get some data, we're going to populate this. So we're going to say set all tweets to tweets, right? For time being, I'm going to comment this. And here we want to say, so if we are trying to fetch it and we have not fetched it at all, so if you're still waiting to fetch data, we're going to say if not all tweets dot length. So if the length is nothing, basically, so if you're still fetching or if there's an error, we're not able to fetch the data, we don't want to return this, we want to return something else. What do we want to return? Well, we want to return, this should have a padding of 5, margin of 5, background as yellow, and maybe some opacity. And within this div, I'm gonna say it's 3, loading, please wait, like this. Now if I go back to my index page, I should see this, lovely. And we're gonna uncomment this because as soon as we are able to fetch these tweets, we would like to set it here. Now we are setting a bunch of tweets on our state variable, and once this is updated, this variable is gonna update it, and once this variable is updated, it's gonna render something else. Okay, so we go back, we're gonna refresh the page, hard refresh, so that we see loading coming up for a moment, and then we get this, which means it takes some time to get the data from blockchain, and now we are able to see this. Now all we need to do is, instead of saying getting index blah blah blah, we just need to render our tweets. So let's do that. So we're gonna say all tweets dot map, right? We're gonna map it so we get one tweet at a time. We're gonna get an index, and now within this we're gonna say return tweet card that we just created, and we're gonna pass tweet as parameter, and we're just gonna give it a key so that next doesn't complain, everybody's happy, like this. Okay, so what we are saying is that, hey, try and fetch all the tweets. So we're gonna just remove off the console logs, we don't need them anymore. So we are saying start with an empty tweet, fetch it from the blockchain. As soon as you get it, put it inside this state variable, and once this variable is hydrated, it's populated, we're just gonna run a loop on it, and we're gonna just return this tweet card. So within our tweet card, we're not doing much, but I know that I'm returning something like this, which means I should be able to see as many cards as there are tweets. So 1, 2, 3, 4. And you should feel comfortable about it, because if I go back to explorer.solana.com, you should feel quite comfortable about it, because I showed you that I have 4 transactions on it, and those 4 transactions are actually the 4 tweets that we fetched. Now all that is left is make it more beautiful and get the data out of the tweets. So let's do that. Within tweet card, what we're going to say is, we will say const tweet. So one tweet should be props dot tweet, right? Props is this variable and tweet is the variable name that we provided here. If you change this to tweet 1, well, then we need to change it to tweet 1. But I'm going to keep it to tweet. Okay. Now, since we have the tweet, we need a couple of things out of it. I'm just gonna do that super quick. Right. Again, if you don't remember why and how, go back to our lib, and on our tweet account we have author, timestamp, topic, and content, and this is what we are fetching right here. Okay. We would like to do this, which means that we are creating a dynamic variable where if user click on this link, they should be able to go to explorer.solana.com with our tweets public key, which is this, and the cluster is Devnet. You can change it to mainnet and whatever you want later when you publish it to the public. Okay. Now let's super quickly fill everything. And sometimes we don't provide topics, then we will say topic. Then card text needs to be, of course, content. All right. We've got two links. I'm going to remove one of these. I'm going to keep one. But as you know, whenever there's a link, we wrap it with link from next, right? So we're going to wrap link with link like this. And then this link needs an href. So we're going to just say ref equals to this variable that we just created. Okay. Okay. And we don't need this. However, I would like to open this link in a new window. So I'm going to just say target as blank. So if we go back to our index page, we got our tweets, topic missing, GKV's tweet, Solana topic, like and subscribe. If I click on the link, it should take me to the Solana blockchain. Lovely. And I can see the transaction. Beautiful. However, we could make it a little bit more good looking, right? So I want this not to take the entire width of the screen. I would like it to come in the center. And let's make a couple of more changes. The subtitle should be good, and we would say who tweeted this and when they tweeted it. Okay. The first thing that I want to do is I want to go to Bootstrap, because whenever something comes to styling, we always go to Bootstrap. Go to Flex, and I want to copy this section where everything is center aligned like this. So we go back. We're going to wrap our card into a different class. So we're going to say div class name as row. So we're going to wrap everything into one row. We're going to paste this so that everything becomes one row. Now within this row, I want to have a column. So I'm going to say div class name column. Whenever the screen size is medium, I want to have a width of 7 like this. And if we go back, now everything should be center aligned. If you're not sure what's happening, I can't stress this, but again, go back and watch that Bootstrap video that I created, and that should help you. I'm going to give you a bit of a flavor. So I'm going to just say background danger, and I'm going to say background primary, so that we have two different colors and we understand what's happening. So the blue one is the row and the red one is the column, right? So danger is red, primary is blue. And what I'm going to say is, I'm going to say for every column, I want some padding. So I'm going to say padding is 5. I'm going to say margin is 3. Now you see that, and let's do one more thing. We're going to say margin of 2 for every row as well. Now you see the difference. So every row, the blue one is a row, the red one is a column, and within that we have our card. Okay. I'm going to remove all the colors and we're going to keep the padding the way it is so that it looks much better and much nicer. I'm going to say margin in Y direction should be 3. You can play around with it, that's up to you. And I'm going to say background as info and I'll give it some opacity. Let's say of 10. I want it to be rounded. And we're going to remove. Okay, now our tweet looks good. I just want to point out one thing, that this tutorial is not about Next.js or Bootstrap. It's more about learning how to get data to and from the blockchain. Okay, perfect. Now we got our tweets. Let's make it a little bit more beautiful. So instead of saying card link, we're gonna say view on Run Explorer like this. And I'm gonna copy another section, and I hope this should be okay for you to follow up. I will import it like this. Now everything works fine. We are saying that the author of this tweet is this public ID, which you can see is also my ID. So 1, 2, 3 tweets from my ID, and the another one is from the random ID that I used. Okay, you see the date and time, and you can also see it on the Solana blockchain. Everything works fine. And now we should understand that we are able to fetch data, and eventually I would like to fetch my tweets. So when I click here, I would like to fetch all the tweets that is related to this wallet. And to do that, we need to filter tweets, right? And since we know that we're going to use filters, let's create a couple of helper functions for us to do that. Okay. So I'm going to go to my list folder, and here I will create a new file. I'll call it fetch tweets.tsx like this. Here I will say export const and create a function. I'm going to call it fetch tweets. It's going to be asynchronous function. It will take 2 parameters. It will take program as an input. Type will be program, of course. And it will take a couple of filters that we can use in order to filter out the data, right? And here, as you know, we'll say const await because it's an asynchronous task. You know this already, program.account.tweet on Solana. Just want to point out that this tweet on Solana should be equal to whatever name you gave to your account, and of course in camel case. So if you gave it tweet on Solana GKV, then you need to change this accordingly. Okay, you need to say GKV like this. Okay. Anyway, I'm going back, undo this, come back, and then we want to say all. And within this function, as you can see, it says you can also provide a filter. That's our list of filters that we want to put here. And once we have everything, we just want to return this. Okay. Now, if filter is nothing, then we're gonna fetch everything. If we provide some filters, we're gonna just filter tweets on that. And since we're talking about filter, let's create 2 filters, one for author and one. Now, since we're talking about filters, let's create one filter that we're gonna use. So I'm gonna say export const author filter, which means that if someone sends me a public key, so AUTHOR then CMP, within this I want to have an offset of how many bytes? 8 bytes, because if you remember, this is the discriminator, and I want bytes, and that should be author's public key like this. Okay, with these 2 functions, we should be able to fetch our tweets, and we should be able to filter it by author filter. Now let's see that in action. So I'm going to copy this. We'll go back to index page. Since we are using use effect, we cannot use await because this doesn't support asynchronous functions. So unfortunately, we have to do this tweets, right? And this will take program as an input. This should fetch us all the tweets, and everything should work on our front end. Nothing should change. We got 1, 2, 3, 4. Perfect. In Bootstrap, if I go up in forms, I should have form control. And technically this is I want. So I'm just gonna copy this and I'm just gonna paste it. Okay, so we've got a filter button and we got a text box where we can type something. Perfect. Opacity doesn't seem to be working because I misspelled it. O-P-A-C-I-T-Y. Much better. Now what we want to do is whenever we click on this button, we need to read data from this input and then put a filter on our text tweets. So how do we do that? We need two different things. First thing we need is a state variable. So we're going to say const author set author. You could name it whatever you like. I'm just going with author. Use state, and we're going to initialize it with an empty string. And we also need const author, and we're going to call another hook called useRef. Then we're going to use this useRef hook and we're going to bind this to our input box. So we're going to say ref is equals to reference to author. This ref is not HTML tag. This is provided by Next. Okay. And when we click on this button, we want to do something. So we're going to say on click handle author filter. We have not created this function, so we're going to create this now. So we'll say const. Within this function, the first thing that we want to do is we want to read the value of the text box. That's how we're going to use it. And I'm going to just log it, so that we are sure that it's working the way it should. I go here and click. We've got an error which says authorref not defined because the name of the reference is different. Okay. Clear everything, click here, nothing comes up because there's nothing there. And now it should be able to fetch whatever I write here. Perfect. So what I'll do, I'll just copy this address, paste it here and filter. Now we get the public key of the author. And all we need to do is we need to pass this value to the function that we created. So let's do that. So the moment somebody clicks on this button, what I want to do is I want to say set author to this author filter value. And we're going to write another hook. We'll say use effect. This effect should get triggered whenever there's a change in the value of author, right? Within this function, we're going to check if author is not equals to empty. So if it has some value, we're going to say fetch tweets program. Of course, we're going to pass the program, and then we want to pass author filter. So we're going to say author filter like this. Within that, we want to pass our author, and once this function returns everything, we just want to say then. So if everything was okay, we should get our tweets. And the moment we get our tweets, what do? Well, we set all tweets to tweets like this, and hopefully everything should work. So if we go back to our app, if I copy this, paste it here and press filter, it should filter everything, and now we get tweet only from this particular author. Lovely, right? If I go here, copy my address, paste it here, now I should get 3 tweets, 1, 2 and 3. Beautiful. We are able to read data from the blockchain. Now let's go and super quickly see how we can write data to the blockchain. And before that, let's also finish my tweet because this is almost equivalent to filtering data. So let's do that super quick. I'm gonna copy everything that we have on our index page. Go to my tweets, paste everything, change it to my tweets. And down here, change it here. Now this one is rather simple and we need rather less things. We need program, we need connection, and we need adapter wallet like this. The first thing that we want is we need to know our public key. So we'll say const my public key equals to adapter base 58 like this. Okay. We're gonna remove all of these because we don't need this. We only need my tweets. This time, whenever we load our page, we would like to fetch the tweets. Sure. However, the filter would be my public key. And we don't need the author. We don't need the handler because we're not clicking on a button. That means we also don't need this. Simple, right? So now if we go back, I go to my tweets, I should see tweets only coming from the author, which is myself. And if I go back to homepage, I should see all the tweets. So from this author, from myself, and everything. Okay. If we click and disconnect on our wallet, the my tweet should not work because it doesn't have the accounts owned by this function. And we should be able to handle that in a moment. But in general, this button should get disabled. And to do that, let's super quickly fix that actually, because we don't want people to see this error. Rather, I would like to have this button disabled. So if we go to our components and if we go to our layout, in the layouts, we should be able to figure this out. We're gonna say use wallet hook, and with this, and we also need router because we would like people to go from one place to another. Then we'll create constant logged in. So this is the state variable. So set logged in equals to use state, and initially this will be false. So our user is not logged in, so wallet is not connected. And here we will say use effect. We'll say if anchor wallet object dot public key. So if this exists, then set logged in to true. Else we will say set logged in as false. And the moment we do that, we would like people to go back to the home page. So we'll say router dot push to the home page. And we want to do that only when there's a change in the anchor wallet object. Okay. Perfect. Logged in is equals to logged in. And then in the nav bar, we're going to use ops. And this will be of type any so that it stops complaining. And we'll say const is equals to props dot logged in like this. And if this is not available, then we assume that it is false. Now, once we do that, what we want is this button which says go to my tweet. This should be disabled. So we don't want people to be able to click on this. How do we do that? Well, the first thing I want to do is I want to change this to a button. Technically, everything should be still remain same, right? And now we want that this button should be disabled. So we'll say disabled equals to not logged in. So if people are not logged in, then we want it to be disabled. And now this button is disabled. We cannot go to this page. Now if I go here and say connect to my wallet, now if I go here and disconnect, I'm not able to click on the button. If I go and connect to my wallet, now this should appear, and if I click here, I should be able to go to this page where I only see my tweets. If I go here and disconnect, I should be routed back to the home page. Perfect. Now the last thing that we want to do is we want to be able to write new tweets on the blockchain. So let's quickly do that. It should not be very difficult because we are master of working on Solana blockchain. We will create a new component. We got it. Create new tweet, and you know the drill. Will say const. If we think about for a moment that how will you create a new tweet? Well, to create new tweet, we would need a couple of things. The first thing that we need would be a topic. Then the second thing that we need will be a container. I'm going to copy paste a couple of things super quick so that this component is able to display everything that we want. And then we're going to hook it up to the Solana blockchain. Okay. Copy pasted a couple of things. And I copy pasted a couple of things. And now let's see how this looks. So we're going to go back to our layout. And after the nav bar, what we would like to do is we would like to have this new component called create new tweet. And now this looks beautiful. We have tweet topic. We can type a topic. We could type the content, and we should be able to click on the button to be able to tweet. And this button should work the same way my tweet works. So if we are able to go to my tweet, we should be able to tweet. So let's see, what did we miss? Okay, we are not sending this prop, so let's do that. Now it should work. So if I go and disconnect, I'm not able to go to my tweets, and now I'm not able to tweet a new tweet. But if I connect to a wallet, I should be able to do that. Perfect. Now all we need to do is we need to write a new function that should be able to send data to the blockchain. So let's do that. By now you should be actually quite comfortable by understanding what to do and how to do things. So the first thing that I want is when we click on this button, we would like to read these two data, and then we should be able to send it to the blockchain. Okay. So let's see how we can do that. And you should by now know how to do that. So we created this function which we bind on this button, and the function is on click. So whenever we click on that button, we're gonna go into this function, and here topic is equals to ref topic dot current dot value, current not content. So if we clean everything, click here, I got it. So like the video 2 times because both are same. So this should be ref content, and this is why you want to always log it, because you want to check if you are reading the correct thing. So like the video, this is amazing. I've got all the data. Now let's super quickly create that function that will send everything back to the blockchain. So I'm gonna go to my favorite lists folder, and here I'll create a new file and call it send tweets. You can call it or whatever you like. I'm just calling it send tweets. So here we'll say export. This will be asynchronous function, right? And it will take a couple of objects as an input. So I'm just gonna copy paste that. And by now you should know why and what do we need as an input. Now within this function, the first thing that we want to do is we want to create, I hope you are completing my sentence. We want to create a new tweet, and that will be a brand new program. So that will be key pair dot generate, like this. This one statement will create a new tweet program on Solana blockchain, and it will have a new public key pair, private and public both. Okay. If we want for debugging purpose, we can always log it like this, and then we will say await program dot methods. We should have a method send tweet on it. How do we verify? Well, there are two ways. Number one is you could always go back to your Solana tweet, and here, should be able to go to your lib.rs, and here you should know that you created a function called send underscore tweet, which is converted to camel case for us. And we also use this in our test here where we said send tweet, and this is the same function that we want to use here. we go back to where we were, and within the send tweet, what do we need? We need topic and we need content. Okay. Once we do that, we want to send all the relevant accounts, of course. The first account is my tweet, and that should be simple tweet.public key. Again, I want to remind you, and this is critical because if you don't know this and if you are stuck, you're going to be stuck for a really long time. The account that we are sending my tweet should be exactly equals to what you created in your libraries. That should be exactly equals to this. Again, from snake case, it became camel case, but this is what you need. If you have renamed it to my tweet ABC, then you need to write my tweet ABC. Okay. So that is there. Then we need sender of tweet, and that will be anchor wallet. So whoever is connected, and their public key. Again, just one more time, sender of tweet is the account that we created here. You could have called it author if you want, and then you need to write author here. For the sake of simplicity, I call it sender of tweet. Therefore, you need to call it sender of tweet. Okay. And then we need system program. And this should be simple enough because Web3 will give it to us. System program dot program ID like this. Then we need people to sign the transaction, right? Because if we don't know who is sending this transaction, we will never be able to put it on the blockchain. Therefore, this tweet, whoever that owns this tweet should be able to sign it. And then we just call RPC. And that, ladies and gentlemen, it basically defines everything that we need to define in order to send a transaction to the blockchain. Okay. Last but not least, we can actually fetch this particular account that is created for us, and then we can just simply return it. If you want, you can do this. If you don't want, you may not return it. That's up to you, but that's how it is. Okay. So once we created this, I'm going to close this. We're going to go to our create new tweet. Now, whenever people click on this handle new tweet, what we want to do is we just basically want to call that function, and then we are good to go. So here we'll say const new tweet is equals to await send tweet. It needs a bunch of things. So first thing it needs is topic, and it needs content. It also needs anchor wallet object, it needs adapter wallet object, and last but not least, it needs the program. Once everything is good, we would like to log the new tweet that we created. I'm going to comment this out. Now is the final step and the moment of truth. So everything that we have been doing so far should work. So I'm just going to give it a hard refresh just for the one time. So everything is fine. We are able to connect to the wallet automatically. We are able to filter the tweets. And now we are ready to tweet a new tweet. So I'm going to say, much like a broken record, we will like the video. Stop saying it. All right. Shall we click? Okay, let's do that. And the moment we click on it, we get an approval dialog from the Phantom wallet, and it calculates how much Solana is going to cost you in order to push this data on the blockchain. If you approve it, we should be able to push this new tweet to the Solana blockchain. Shall we do it? Okay. Are you ready? 1, 2, 3. Take some time, and voila. This is what we are logging from the console log, of course. Where is it? There you go. And the fact that we are able to log it here, it should be somewhere here as well. So if we go back here, we just need to refresh it. So I'm going to go to my tweets. And there it is. Like the video. Much like a broken record, we will like the video. Stop saying it. And the time is 4th of August, 9 p.m. Oh, it's quite late. Okay, perfect. And with that, I think we have done everything that we wanted to do. If we go and click here, we should be able to see this on Solana Explorer. And the same thing, how much did it cost, what was the time, transaction signature, and everything. Alright, that's all for this video. I hope you enjoyed it and learned a lot. And I know you will take this knowledge to create awesome apps on blockchain. And cheers to that. I will put the GitHub code base link in the description as always. And do let me know what did you enjoy and what you did not enjoy in the comment section. And as I mentioned earlier multiple times, please give this video a like and subscribe to the channel. That's how I know that you love the video and you learned something cool today, and it also motivates me to create more knowledgeable content like this for you. Okay, I see you later.